So we are going to make a fluid disintegration. Let's begin. So we are taking some animated geometry. After that, take a point from volume, giving some dense point number 0.01 for point separation. Why we are choosing point from volume? Because the volume transformation which are not limited to the surface. Here we can see that. And next step will be our point from deform. So we have to use time shift for rest our animated points. Connect the line as shown in the video. Delete the channel and frame number will be 1. For applying masking we are using pyro source spread. Then take a group node. Group some starting points for mass. For me, identify the bottom point. I am using bounding box. So take a attribute, create and derive the temperature attribute. Attribute name will be temperature and value will be 10. Don't forget to give group what we have created. In pyro source spread, cooling rate will be 0.1. Tweak some diffuse parameter according to your effects. Add null and what we have created are mass. Connect this to the first input of the point deform. Next node will be attribute wrangler. Okay, before that add a color node. Color type will be RAM from attributes. Attribute will be our temperature. Exist like this for masking the edges. So in Wrangler, our wax expression is removing points. If address cd.x is greater than 0.1, so remove the points. Geo handle will be 0. Remove points from the point number. For simulation, just go ahead for .NET. For exact volume optimization, take time shift node. After that, take a loop. In loop, begin create a meta input. In time shift node, create a spare input. Drag metadata to spare input column. After that, connect the animation geometry to for each begin. Changing fetch feedback to fetch input. In time shift node, we are importing the details of iteration. Multiplying the offset. In the end of loop node, method will be merge each iteration. We can see that the animation offset in the single frame. After that, take a box and measure the bond. Now we are ready to work on simulation. In .NET, create a flip solver, flip source, volume source and gravity. This is a basic node require flips in. Change the input type to first contact geometry. And initialize source flip. Read out the show part of the flip object. Copy the parameter of the box parameter what we created for the volume limits. In flips folder, there is an option for volume limits. We need to paste the value of transform and rotation of the box. After that, in volume source, there is option for particles. So read out the source group. Listing will be import our particles. Now go in flip object. In guide, change the sprite to particles. Enable the close boundaries. In the flip object, enable the viscosity. Despite from deforming, keep incoming. Add one more velocity and set to curl noise. In our dope network, flip object separation same as point volume separation. So basically after that, duplicate our point wrangler and duplicate our color node also. Remove the extra points and ramp will be our 0 to 10. In Wrangler, change the more than sign to less than. Copy our object animation and import here. Now we are using attribute transfer. Connect our remove points wrangler after the attribute transfer. You can see that the white portions are gone. So this is a point disintegration. After that, take a scatter node. Increase the total count. Okay, one thing I forget. In dope network, minimum maximum sample will be more. Despite from this, take a pop drag and connect this to the second input of the flip solver. And resistance will be 3. After that, take a VDB from particles and connect it to the scatter node. Exit some parameter, make some bulky collision. And this is our VDB collider. After that, go inside in .NET. Take a merge node. Take a static object and connect to the merge node. Our subpath will be VDB which we created a few minutes ago. Collision detection will be our volume collision and mode will be volume sample. After that, take a VDB from particles and connect our DOP network. Exit the voxel search according to your object. After that, take a VDB smooth and convert VDB. Despite from volume, use polygon. Merge the body disintegration and fluid. Make sure DOP network object is flipped object. In DOP network, static object must check on deforming geometry. Connect attribute transfer to our disintegration geometry.